Here's the shocking part. Most robot chatbots rely on expensive online LLMs, and that means one network problem can shut down the whole experiment. This paper shows a different path. You deploy an open-source model locally, then connect it to a multimodal robotic setup. The system is called Socratic Models ChatGLM. Think of it like giving a robot its own private brain. Not a rented brain in the cloud, but one you run on your local GPU. The authors use ChatGLM 2.6b, an offline large language model, and they wrap it with an OpenAI-style API so you can call it like a familiar service. Now, the magic isn't just chatting. The algorithm is built in three big pieces. First, the large language model handles the text instruction like pick the red block, then move it to the left. Second, vision kicks in, using object detection and visual reasoning so the robot actually understands what it sees, not just what you said. Third, a code policy execution model turns the plan into actionable robot control. So how does this help long multi-step tasks? Imagine giving someone a recipe, but only telling them to guess the next step. That fails fast. Instead, Socratic Models ChatGLM keeps producing code that drives the UR5 arm step by step, guided by what it observes in PyBullet. The paper claims it performs strongly on single instruction multi-step manipulation, and even outperforms prior approaches like code as policies on continuous long-horizon tasks across different environments. And yes, all of this is done with a locally deployed offline model, which means more stability, lower cost, and no surprise billing. If you're building embodied AI, this is a huge blueprint. Want the details on the method, the pipeline, and why offline LLM plus code policy execution is such a powerful combo? Hit like, subscribe, and comment Socratic for a breakdown of the system flow.